These are the 6-week Algebra 1 benchmark review videos. We're starting all the way back with what we did at the very beginning of the semester. That was dimensional analysis, which is just a fancy way of saying conversions. Okay, if there is a conversion that you should not know, it will be given to you. But for example, in this very first problem, we're going from yards to feet. You should know the conversion between yards and feet. So it starts off nice and easy. And I know that if I'm starting with 3.2 yards, that it needs to go up here on the top, and it goes over top of a 1. We have to multiply that by a conversion factor or a series of conversion factors that are going to allow us to get to our end goal, which is feet. Well, there's actually a direct correlation between yards and feet. Of course, that is, there are 3 feet in 1 yard. Well, that means I need yards to go on the bottom so that units can cancel out with units, and feet have to go up top because that's what we want to finish with. And it takes 1 yard to make 3 feet, or vice versa, 3 feet to make 1 yard. Now I see my unit cancellations. So all I'm left with is feet like I wanted. 3.2 times 3 is going to be 9.6 feet. Nice little easy start. Next, we actually leave the American system, and we're going to start looking at the metric system. For the metric system, you have to memorize this little series of letters. Okay, and we had a little rhyme to go along with it. That little series of letters was King Henry died unusually drinking chocolate milk. And yes, I know that's a little bit of a younger thing maybe to have little sayings like that. And maybe some of y'all haven't had one of those in a while, but a lot of people remember it. I told you the story during class. I had a student come back to me that's in chemistry right now, and they remembered that. They needed it and they remembered it for chemistry. But we're going from grams to hectograms here. And if you remember, you can do these with conversions, or you can just move decimals. We learned the metric system's easier to deal with. It's just some decimal moving. So I need to start at grams. And I look down through here and I realize there's no G here. That's because this middle term is unit. That's our meters, our grams, our liters, all of our bases. That's what it used to be, was a B for base. But now it's our base unit. That means we're starting here with grams. Coordinate that, starting with grams in red. And then we want to move to hectograms. Well, hectograms is an H, so we're going this direction. That means we are going to take 2 hops to the left, which means we move our decimal 2 places to the left. That's what that tells me. 2 hops means move our decimal 2 places to the left. Well, my original number was 2,500 or 2,500. There was no decimal there. But if there's no decimal, I know that it's hidden right there. We move it 2 places over, and we have 25 hectograms. 25 would be C, and we're rolling right along. Number 3, we're still doing conversions, but you can see right underneath it, it gives us some specific conversions which we need to use on this problem. 3,500 kilograms into tons. That means we're going from metric to English. But again, we're going to start off, if we're doing a true conversion, with 3,500 kilograms over 1. Sometimes this is per, and that, like on number 4, where we'll have a unit down there, but for right now, we're just starting off with just a 3,500 kilograms, basic amount. We need to do something to get this end goal of tons, okay? So I can write it like way out here, tons. I don't know if I'm going to get that far out or not, but I know my end goal is to get to tons somehow. Well, I don't know much about kilograms. I could convert it to grams and things like that, but I look here and I say, oh, they told me something about kilograms. They told me 1 kilogram is 2.2046 pounds. Oh, and that's good. Because I know how many pounds are in a ton, 2,000. Or, in case you forgot that one, because that is a fairly rare one, it does say it on here as well. In other words, it's given me a conversion to go from kilograms to pounds and then pounds into tons. And that'll get me to my final goal, tons. So this first conversion factor is 1 kilogram over 2.2046 pounds. Okay. That's going to get rid of kilograms and leave me with pounds up top. That's one step closer to my final goal. Next, I use my other conversion factor. 2,000 pounds, notice the 2,000 has to go on the bottom now, is 1 ton. Pounds cancels with pounds. Now I do a unit check. Across the top, the only unit I have left are tons, and across the bottom, I have no units left at all. That means I am, in fact, in tons like I would like to be. This one, however, is not one that I'm going to try to do in my head. Okay, these are some big numbers being multiplied and divided together. So I go into the calculator, clear out whatever's in there, and I'm going to do it just the way it's written up here as big fractions. Alpha y equals, enter, 3,500 over 1 multiplied by another fraction, 2.2046 over 1. Oops, well, I'm supposed to press enter yet. I can go back up there and grab it. It's okay. Times our final fraction of 1 over 2,000. So 1 over 2,000. Please ignore that 7,000 number. That was before I got all of it typed in. Double check, make sure our decimals and numbers all look like they're in the right place. They do. I press enter and I get 3.85805. I would just round to 2 decimal places here most of the time. But since I have an actual problem, I can look at the answers. I check to see what they did. Ooh, it looks like it's actually rounded incorrectly here. I'll make sure to fix that on y'all's. 3.85 should round to 3.86 here. So that's what I would say. I'd say this is 3.86 tons. Of course, there's no perfect answer there, so 3.85. But that would give me a little pause for concern if I was taking this test. I'd be like, ooh, did I mess the math up? Because that's not rounded right. Please be careful with your rounding. I'll make sure to fix that on y'all's. On to number 4. This is one of those great conversion problems because it starts us off with units on the numerator and on the denominator. We're starting out at 10 feet per 1 second. And in the very, very end, all the way down here, I don't know how much space it's going to take. I want to get miles per hour. Miles per hour. So you got to decide how you're going to attack this. Basically, you either need to go from feet to miles first, or from seconds to hours first. Whichever one you would like to do, choose one of the units to work on first. Don't try to mix and match and do them at the same time. I usually just go after the top unit of feet. I go after whichever unit came first. Well, I know how many feet are in a mile. You should know that one, but in case you don't, it's here for you. 5,280 feet per mile. So, multiplying by a fraction, 5,280 feet go on the bottom, because I need feet to cancel out with feet. I need miles up top. So this is just a fact. We use the fact given to us, and we just have to figure out which way to flip it depending on what miles, or what units we need to cancel out. So there's that conversion factor. Well, I need miles, and now I'm in miles, so we're good to go. For distance. For time, on the other hand, we're in seconds and we need hours. Now, most people don't walk around with the knowledge already in their brain of how many seconds are in hours. We have to take it one step at a time. I don't know how many seconds are in an hour. I know how many seconds are in a minute. So that's the direction we're going in. I need seconds to cancel out with seconds. And I said I was going into minutes. Okay? Well, I know it takes 60 seconds to make 1 minute. Seconds cancels out with seconds. Now I'm in minutes. It's a small little jump to get to hours here. I know it takes 60 minutes to get to 1 hour. Cancel out, do a unit check. I wanted to be in miles. I stayed in miles. Notice how they all canceled out. I wanted to be in hours, and I got to hours. Now I'm ready to produce a final answer here. A lot of fractions here. You can multiply straight across the top, straight across the bottom, or you can do them all as fractions. Once you get used to typing in the fractions, it does not take that long. It takes me a while up here because I have to just do one tap at a time with this pen, but you'll be a little bit faster at it. It was then 60 over 1 and 60 over 1. Again, if you're sitting there going, wait, why is it doing 60 over 1? Isn't that just 60? Yes, it is. But it really helps a lot of people if they can visualize and see all of these out there. Okay? We press enter, and we see it to be 75 elevenths. I'm like, oh, great, cool, let's go to up. That doesn't show up anywhere. 75 elevenths isn't showing up there. This means you have to reevaluate this fraction as a decimal. There's a couple ways to do that. One, you can just do 75 divided by 11, or two, we've seen this math button. So we go math down to arrow decimal. And what it's going to do is going to take my last decimal, or my last conversion, my last fraction. Cool. I really struggle on that word. It's going to take my last answer here, which happens to be a fraction, and turn it into a decimal. And I get 6.81 repeating, which would be 6.82. Again, you can also just do the division itself. Remember, a fraction is just a really churched up way to do division. 75 divided by 11 is, again, 6.8181, which rounds off to be 6.82 miles per hour.